I now have a website for book reviews. At the moment I have The Ballad of Songbirds and Snakes and The Hunger Games, and I aim to post at least one review a month. So if you want to check it out, the link will be in the description. Transforming graphs. So this is a concept you will come across at GCSE maths, and it can be a little bit confusing, and hopefully this video will make it a little less confusing. So let's go. So the first thing I want to talk about are functions, because this is basically the graph, in that is being transformed. So I'm just going to do a brief overview on this. So a function is f of x equals to something, let's say x plus 1, and this means that when you're given a value for x, so x is 2, what you do is you replace the x, you substitute it in the x, and you would get f of 2 equals 3. Okay, so you just substitute in both places, and this is a function. And when you have it as a graph, what happens is, in an exam, say, they will give you a graph. So it will normally look something like this, loopy, and they'll tell you that this is the graph of y equals f of x, and you don't have to find the equation of that line, this loopy line, because that would be hard, but you just have to take it as being the graph of f of x. Okay, so yeah, so you have y equals f of x, and say now when they ask you what is f of, like, say if x is 0, what is y? So you have f of 0, what is f of 0? So you look here and you put x equals 0, because you can just do it as you would normally do anything on the graph. You look, x of 0 is here at the origin, so what is y here? Well, it is also 0, because the line passes through the origin, so you'd write 0 as your answer. So you're basically being given an x value, and you're looking at the graph, finding it, and then writing that as the y value, and that is the answer to f of whatever your x value was. So let's do another example. Let's do x equals minus 1. So what is f of minus 1? Well, we look here, minus 1, and I know I haven't actually shown this before, but let's say this is 1 and this is 2. 2 is actually a little bit high, imagine that. So this is 1 and this is 2, so you go across like this, and you see that it's halfway between 1 and 2 on the y-axis, so it would be 1.5. So next is minus 1, y is 1.5, so that would be f minus 1. Okay, so this is the fundamental of it. And now we're going to talk about the actual transformation, which is where it might get a little bit difficult. So when you transform something, you change it. So you have y equals f of x, and what you can do is, let's say you add a value to that. So you basically change the equation in a way. So y equals f of x plus 1, you add a 1. Or you do y equals 3f of x, you multiply by 3. And you can also do this within the brackets of f, so it would be f of 3x, you times the x by 3. So now when you look at what x of 0 is here, wait, no, that's a bad example. When you take x of minus 1, originally, down here, you had it as 1.5. Well, this minus 1 is now times by 3, so it's minus 3. So you look where minus 3 on your graph is, and you find the value of y there, so it would be down here somewhere. I hope that makes sense. And that is how you then take it. So let me just talk about that a bit more. So let's take a relatively easy transformation and do y equals f of x plus 1. We've just added 1 to the end result, and this is a transformation of this graph here, y equals f of x. And now let us take x equals 0. So x equals 0. Nothing happens to the x, so now we have y equals f of 0 plus 1. We go back to our graph, we find f of 0, so when x is 0, which as we've established before is 0, we put that there, 0 plus 1 was 1. We're now told that y is 1 when x is 0. So let's just plot this point. So x is 0 down here, and y is 1 up here. Okay, so this is the first point that we have. Now let's do this again. Let's take x equals minus 1. So we put that in the function, so y equals f of minus 1 plus 1. What is minus 1? We've established before, it's 1.5. Y equals 1.5 plus 1, so that gives us 2.5. So now we're told when x is minus 1, y is 2.5. So let's go here, minus 1, 2.5. So this is 3, this is 2.5. So this is our second point. And if we keep doing this, we will actually see that basically, wait. Oh. Well, this is very bad, but you will basically see that now, this is y, oh no, y equals f of x plus 1. So now that this is y equals f of x plus 1, we have now graphed our new equation, function, and we have transformed the original y equals f of x into something new just by adding a 1. And this is basically transforming graphs. You are taking a function or graph which you were given, and you are either multiplying something or adding something to it, and it changes what that graph looks like. So this is quite interesting, and as you see here, we've been doing it by trial and error. So we found x equals whatever something on the original y equals f of x, and then we've tried it in our new graph, and then we've plotted that point, and we keep doing that. But this can be so this can take quite a bit of time. So a faster way to do this is just by remembering these 6 things that you will need to remember for GCSE, and the only thing that they'll actually ask you. And this can be very useful. So I'm going to write them down here. And yes, let me just write them down. So the first one is y equals f of x plus a, where a can be any integer. So we've done this. In our case, a was 1. And we've seen that what happens is the graph, or the equation, the function moves up 1 on the y-axis. So this, if you would have to describe this transformation, if you would say, I think they will give you the mark, I'm not really sure, but you could say it moves up 1 unit on the y-axis. And a better way to say this is it is a translation of 0a. So if you've done transformation, you should know this. I might make a video on that. And it's quite simple. So this is the x, and then this is the y value. So a means that whatever the y value was before, you add a onto that. So let's say we have x is 1, and in the original, let's say we have y equals f of x, and we have x as 1, and y was 2. Well, now that we've got f of x, y equals f of x plus 1, this changes to 1 being the same, because we have 0 here, so it will be 1 plus 0, and 2 plus a, which is 1, which is 1, 3. So the new coordinate would be 1, 3 from 1, 2. So that's the translation. So if you remember this, any value they give you, so let's say it's y equals f of x plus 200, you don't have to count up 200 like units on the graph. You will just add 200 to the y value, and that will make your life a whole lot faster and easier. So that's the first one. Next, we have y equals af of x. So here we multiply f of x by something on the outside. So again, a can be any integer, or, well, yeah, any integer. And what you would do here is, the technical way of saying it is stretch scale factor a from x axes. And what this really means is, let's say your coordinate was x 0 and y 2. If you would put this down on a graph, you'd have it here, correct? This is 2, this is 1, this is 0. So you would have it here. And so we look here from the x-axis. So how far away is this from the x-axis? Well, it's 2 units away. Now, let's say this was our point of y equals f of x. Now we're told y equals 3 f of x. What you do here is you stretch scale factor a. So when it has a scale factor, you multiply by that. So if it was 2 units away, you multiply that by 3. And what is 2 times 3? 6. So this becomes 6 units away. So it goes here, where it's 6. Because it's 6 away from 0, which is 6. So if your graph looked like this, after y equals a f of x, where a will be, it will be greater than 1, so it will increase, it will look like this, maybe. Basically, it would just get longer, or yeah, in a way, it will be stretched like this. So it's like when you have a cube, you would stretch it, and it could be stretched obviously, you would stretch it like this, and it would become this, it would become bigger in a way. So that's what that does, and the language for that is stretch scale factor a from x-axis. So in a way, you're multiplying by a, and then putting that distance from the x-axis. Next, we have y equals minus f of x. And the technical way to say this is reflection in x-axis. And I think this is pretty straightforward. You're just reflecting it in the x-axis. So the x-axis is the horizontal. So if you had something like this to reflect it, you would, so you'd keep the points of intersection, and let's say this was 2 away, you do 2 away in the other direction. And then you go like this, and that's what it would look like. So you just reflect it, and this is minus f of x, and that's really the only thing that can be. So you just reflect whatever the function is. And this is half of what you need to know. And if you've noticed, all of these affect the y direction. And what this means is so the first one makes something go higher up the y-axis or lower down the y-axis. The second one makes something get stretched further up the y-axis, or further it gets squashed but across the y-axis. And the last one changes where it is on the y-axis. So if it was at y equals 2, it will become at y equals minus 2 because it gets reflected. So all of these affect the y direction, and the second set you have to learn affect the x direction. And the only difference, well, the difference in this is that everything you had here, so plus a times minus 1, this moves inside of the bracket. So y equals f of x plus a, y equals f over ax, and y equals f minus x. Everything gets moved inside the x-axis, and this affects the x direction. And it would be nice if it was just this easy, but obviously these would also have to change a little bit. So so let's start with the first one. So here it would be translation minus a 0. So what you would do is, if a was 1 here, so you have f of x plus 1, what you do is you'd have minus 1, 0, and as we said, the top is x and the bottom is y. So this would be minus 1 x units. So if x was 2, it becomes 1. If x is 3, it becomes 2. Okay? And if a is negative, then a negative and a negative make a positive. So you move to the right on the x-axis. So if x is 2, it becomes 3 because you add 1. Obviously, if a was bigger, you'd add or subtract more. Well, you'd subtract more because it's bigger. But if a is negative, you would add more, so it'd move more to the right. But it's the negative and the negative. Now, y equals f of ax. Here, you would stretch, I'm just going to write SF, which is just scale factor, 1 over a from y-axis. So here you can see that it is no longer from the x-axis, it's from the y-axis. So you see how many units away something is from the y-axis, so the vertical line. So let's take this point here, this is 1 unit away. And you would stretch this by scale factor 1 over a. So if a was 2, you would multiply 1 by 1 over 2. So this would go here, 1 over 2. And the new point would be here. So to visualize this, if y equals f of x was this, then y equals f of 2x would be this. It would be squashed in a way. Okay, and if a was 1 over 2, what you would have is 1 divided by 1 over 2, which is 2. So here you would increase the distance. So this would become this. It would become wider. Okay, and then finally, this is probably one of the easiest to remember. This is reflection in y-axis. So you just reflect it in the y-axis. So here, if you had this, it would turn into this. You would, that's pretty bad. Yeah, you would just reflect it in the y-axis. And yeah, so these are the ones you have to remember going about this. Writing them down in flashcards would be useful. Just writing y equals f of x plus a on one side, and on the other side you write translation 0a, and you just test yourself until you know these, and then in the exam you'll know these off by heart, and you'll just have to put in the a value and do the actual sum. So with the scale factors, you multiply whatever the y value or the x value is by the scale factors, and 1 over a, or a. Here you would just reflect it in the y-axis, and here you would either add or minus on the x-axis, or add or minus on the y-axis. And yeah, these are basically it. This is what you need to know. Okay, so I'm gonna do one example question at the end now. So okay, so now we're gonna have an example question. So excuse these arrows and this X. I just had to get a graph, and yeah, I screenshotted it. Right, so as you can see, we have a graph. Now I'm gonna do the function, so y equals f of x, and then I'm gonna give some example questions. You can pause the video, try and do it yourself, and then I'm gonna show you the answer. So first of all, let's do y equals f of x. Right, so I want it to go through -2 here. I'm gonna do this in black, by the way. Cross 3, go through 1, go as low as -2, goes up, yeah, goes back 5. Okay, so probably should have planned this a bit more, but either way. This is my y equals f of x. So, now I'm gonna say draw y equals f of 2x on the graph. Pause the video now if you want to give this problem a go. Okay, I'm gonna go through it now. Okay, so y equals f of 2x. So, if you remember from the page before, the formula for this is stretch scale factor 1 over a from y axis, and we're given a as 2, so stretch scale factor 1 over 2 from y axis, as you can see here. Okay, so what does this mean? We find the distance from the y axis and we make that half as big, basically. Yeah. Okay, so let's have a look. So this is 2 here. Let's start with this. So the distance from the y-axis is 2 units, of course. And what is 2 times 1 over 2? It is 1. So this now moves to being 1 unit away. So 1. So we have our first. Okay, now 0 stays the same because 0 is 0 units away and 0 times anything is 0. 0 stays the same. So there we go. We have 2 things. So we can start the graph. Next, here we have, this is 1 unit away. So 1 times 1 over 2 is 0.5. It's 1 over 2. So this will move here to 1 over 2. Next, this unit is 3 away from the y-axis. So 3 times 1 over 2 is 1.5. So 1.5 is here. This last one is 5 units away. 5 times 1 over 2 is 2.5. So 2.5 is here. And I'm not going to bother for the rest, but this is what you would do. And the sketch would be something like this. So this is y of f 2x. Okay, we're going to do 2 more examples. Y equals negative f of x. Pause the video now if you want to give this one a go. Okay, and now, so minus f of x. So we reflect in x-axis. See here? Okay, so let's reflect this. So I said that the intersection points will stay the same with the x-axis. Okay, and now let's take this coordinate. This is 1, 2, 3. 3 units away from the x-axis up. So we reflect it in the x-axis, it will be 3 units down. So we have these points. Now this point over here, this is 2 units down, so we'll move 2 units up. And that's basically it. So this will look like this. Sorry for the bad sketches, but that's what that would look like it would be reflected in the x-axis. Okay, and now for the final one, let's choose green color. We will do y equals 3f of x. Pause the video now if you want to give this a go. Okay, let's go through it. So we've multiplied by something on the outside, so this is another scale factor. So this is stretch, scale factor, 3 from x-axis, as you can see here. Okay, so what does this mean? We find the distance from a point to the x-axis, and we multiply that by 3. So let's start with this one. Well, this is on the x-axis, so it stays the same because the difference is 0. So the intersection points will stay the same. Okay, now here, over here, and this one. So this is 1, 2, 3. So it's 3 units away. Okay, so 3 times 3, because the scale factor is 3, so we have 3 times 3, that's 9. So this will move all the way up here to 9. Now, the next one, here, it's negative 2. Negative 2 times 3, that's negative 6. So this will move all the way down to negative 6. Okay, so now if we go through these points, this is what our graph will look like. Y equals 3f of x. So yeah, that's an example question. So that was transforming graphs. I hope that it was not too hard to understand. Of course, if you didn't understand something, you can always look on the internet, or you can write a comment down below asking me to do a video, and I might focus more on one of the things that I didn't explain too well. So feel free to do that. I hope this video has been helpful. Thanks for watching, and bye for now.